Hey guys, Rhett Richardson here. Welcome to my third video from VCE tutoring. Today we're going to be looking at a question that comes from Unit 3 Physics. So this is relevant for Year 12s. It assumes that you have knowledge of constant acceleration, the equations underpinning constant acceleration and motion, as well as resolving components for velocity. So we'll get stuck into the question. For 8 marks, an amateur golfer of mass 70 kilograms hits a 25-gram golf ball from an altitude of 30 meters vertically above the ground. We call this the green. The golfer hits the ball with an initial horizontal velocity of 20 meters per second. Calculate the following using the correct number of significant figures. A, the time taken for the ball to reach the ground. B, the distance the ball travels to reach the ground, the range. C, the final velocity of the golf ball and the angle at which it hits the ground. And D, describe your key assumptions in this analysis. So for those of you that want to jump ahead, more of the answer first. Here is the question as I prepared earlier. I'll just scroll through this for you. Feel free to pause the video and have a look at the answers here. C and D. Okay, so I like to start off analysing physics questions by just drawing a picture. So here's one that I prepared earlier to save some time. So we have our golfer. He's located 30 meters vertically in the vertical direction above, and my golf green down here. So physically what's happening, this golfer is hitting his golf ball initially with all horizontal velocity of 20 meters per second. Under the influence of gravity, the ball drops and follows this parabolic shape down to hit the green, hopefully land and bounce into the hole. Now, I've written out the key pieces of information that we know from this question. So we're told that we've told the golfer's mass. It's a 25-gram golf ball. You're 30 meters vertically above, and you have an initial horizontal velocity. Okay, so in order to calculate A, the time taken for the ball to reach the ground, I need to analyse the vertical component. So we're going to analyse the vertical component of the velocity. So at this point here, I'm simply going to write out everything that I know. So note that I'm going to use subscripts here for V to mean the velocity in the vertical direction. So I know initially in the vertical direction the vertical component is 0. X, being the distance vertically, is 30 meters. The acceleration due to gravity, I'm going to take this as 9.8. Other books and exams take it as 10. Sorry, ms minus 2. And this is also down. So these are all downwards. And I want to know time. So I have in the back of my head, these equations here, the constant acceleration, and I'm looking for one that satisfies the variables, so x equals ut plus 1/2 of at squared. So for these variables, x equals ut plus 1/2 of at squared. Now I'm just going to write this equation again with the correct subscripts and then calculate t. So xv is equal to plus 1/2 at squared. So then substituting the numbers, 30 is equal to 0 times t plus 1/2 times 9.8 t squared. So rearranging this, I would be left with t is equal to the square root of 30 divided by 4.9. Okay, and then punching that into my calculator, square root of 30 divided by 4.9, 2.474. Okay, and now for noting that I need an appropriate number of significant figures. In the question, all the data I'm given is to 2 significant figures. So I'm going to round this to 2.5 seconds. Okay, that's the answer to part A. Now for part B, the distance the ball travels to reach the ground. This time I have to consider the horizontal component of the velocity. So, according to my part A, it has taken 2.5 seconds for the ball to travel from here to where it lands here on the green. Now, that same time, if we analyze the horizontal component, the ball is moving at 20 meters per second horizontally, and this is a constant velocity all along here. Going downwards, the vertical velocity is changing. It started at 0, and it gets bigger and bigger and bigger in the downwards direction, and it will be at its maximum right before it hits the ground. So, in order to solve for the range, or how far the ball travels horizontally, we're going to analyze the horizontal component. Okay, and so I have the initial velocity horizontally is the same as the final velocity horizontally, which is equal to 20 meters per second. The time taken, I'm going to use, as we worked out before, for 2.474 seconds. In order to work out x horizontally, it's simply distance equals speed times time. So speed times time. So that's going to give me 20 multiplied by 2.474. So taking this number here times 20, I get 49.487. Which I would take to 49 meters. Okay, so the ball has travelled 49 meters in the horizontal direction to reach here. Now part C, this is the real meat of the question, the final velocity of the golf ball and the angle at which it hits the ground. So, in this analysis, I first need to work out the final vertical component. So this final vertical component here of the velocity, I know that the final horizontal component is still 20, because that was constant all through the motion. So once I know this vertical component, I now know the horizontal component. I can use Pythagoras Theorem to calculate this hypotenuse, so c squared is a squared plus b squared. And finally, I can use trigonometry to work out the angle. So that's what I'm going to do now. So, for part C, again, we're analysing the vertical component. Okay, so what do I know? Similar data, sorry, the same data from before. Downwards, the x is 30 meters. Downwards, the acceleration due to gravity is 9.8. And I want to know the final velocity in the vertical direction, v subscript v. Again, considering my equations of constant acceleration, I would land on v squared equals u squared plus 2ax. Note here that even though I have the time in the analysis, I'm going to try to avoid using it again, what I calculated up here. Just in case for some reason we had made a mistake in here, I'm going to use the data that the question gave us in part C. So, writing that with the subscripts, the final velocity squared is equal to the initial velocity squared plus 2 times a times x. X in the vertical direction. Substituting in the numbers now, so that's 0 plus 2 times 9.81 times 30. Now, 2 times 9.81 times 30. Sorry, 9.8. 2 times 9.8 times 30. 588, so the final velocity would be the square root of 588, which is equal to 24.2425, so I would take that to 24 meters per second as velocity. Okay, so that now is the vertical component. So what I'm going to do is take the two components, and just to illustrate it to you how I combine them, head to tail, the vectors. So I've got the horizontal component here, which is 20 meters per second. UH equals 20. I've got the vertical component here, which I just calculated, slightly longer in magnitude, is 20, VV equals 24.25 ms minus 1. Sorry, I'll just change this to V, final velocity horizontally. Now, the vector that I'm calculating is the hypotenuse here, and this is the overall, the final velocity. The right angles here, the value of theta in here, and note also the actual angle to horizontal. I'm going to call this, I'm going to call it alpha. Okay, so if I work out the angle first, so theta is equal to, now I'm opposite over adjacent, So I'm using tan, so inverse tan of 20 divided by 24.25. Punch that into a calculator. Make sure that's you're in degrees. 39.51 degrees. So then alpha would be 90 minus 39.51. I'll take to 50.5 degrees. Okay, so the ball's going to land at 50.5 degrees to the horizontal. What is the magnitude of the velocity? So again, from the right angle triangle, we basically got Pythagoras' theorem, c squared is equal to a squared plus b squared. So the final velocity is equal to the square root of horizontal squared plus, the vertical squared. So that's going to be the square root of 20 squared plus 24.25 squared. Oops, sorry. $31.43. So I'll take that to 31 ms minus 1. Okay, so just to summarize it as a quick sentence, therefore the golf ball lands with a final velocity of 31 ms minus 1 at an angle of 50.5 degrees to the horizontal. Okay. And finally, for the last part of the question, D, describe the key assumptions in this analysis. Okay, so what have we kind of simplified, or what have we ignored? We've ignored air resistance. Air resistance on the golf ball. So obviously as it flies through the air, in reality it would be influenced by the wind, possibly blown of course. And we've also ignored any spin of golf ball. So we've essentially treated as a point mass. Okay. So that's the end of the question, guys. Now, from a marker's perspective, if we just go through quickly, for 8 marks, you'd be looking at 2 marks for part A, calculation, correct answer, 1 mark for part B, correct answer. For part C, the 3 marks in here, so the mark down here for the correct meters per second, the final velocity, vertical component, the angle, and then using Pythagoras to put them together, and then 2 marks in here for the assumptions to give you a final 8 out of 8. Thanks for watching, guys. As always, feel free to like and subscribe in the video, and good luck with physics.